Hello, my name is Cade Smith. I am the Natural Resource Director for Blue Stem Ranches, a cow and calf operation located in Mitchell County, Texas. Blue Stem Ranches is a 46 ranch located in southern Mitchell County. We run approximately 400 head mama cows and utilize a rotational grazing system along with food plots to maximize carrying capacity and profits. A common problem facing the ranches in the area is the availability of natural watering locations. Even though we have many tanks and have strategically placed along watersheds, the Colorado River also runs along one side of the Blue Stem Ranch. We are constantly seeking alternative energy sources to supply water to the cattle as well as the wildlife, which is also another source of income for the ranch. After lots of research and putting a pencil to the feasibility of different sources, we have decided to invest in a solar energy powered water wells as well as some electrical fencing. This presentation shows some of the information we have considered when making these decisions. That's the 500 pasture we use. There are approximately 481 acres in the pasture that are currently has no separate water supply. When cattle are placed in this pasture, water must be hauled using water tanks. This is very inconvenient and very costly. So let's do the math. 2,880 gallons a day, and that's 27 gallons of water needed per head. 106 cows. Carrying capacity for Blue Stem ranches is one head to 23 acres. So we need a well that will support approximately 20 cows. 20 cows, 27 gallons equals 500 gallons of water per day. Available resources, there's no electricity, no fuel lines, and the cost of delivery to remote areas are not feasible. Cost of sunshine available. Lots of sunshine, excuse me. Need water. Can't make money when you aren't utilizing every acre possible. Can't utilize every acre if not all necessarily life supporting needs are available. Food, water, and shelter. Things to consider. Average per foot drilling costs range from $15 to $30. The factors to consider when drilling a well include permit fees, well depth, geological makeup of the ground, per foot drilling cost, well caps and seals, and well equipment cost. This is before the pump is even considered. These fees and charges vary based on the type of terrain and depth of the water table. In the area we are considering utilizing the solar well, the depth is approximately 150 feet. That would mean the drilling would run around 3,300 to 3,750. The drilling company also charges a per mile fee to come to site. The location is approximately 48 miles from the business location. Therefore, $1.48 per mile, approximately be about $71. This is all the expenses before the actual pump and solar panels are considered. Advantages: physical, reliable and long lifespan. Solar panels' life can be at least 25 years. Environmental friendly, convenient. Making the choice to go solar was an easy decision for Blue Stem ranches. The bottom line in ranching business is that most economic way to make a profit while protecting the land we live on and use. Advantages: pump water anywhere on earth, no external power required. Solar well pumps are more efficient and more powerful than ever before. Systems are modular and can be upgraded over time. Solar wells pumps are easy to maintain. The breakout in solar water pumping is that there is no need for an external power source. The sun and the solar panels provide all electricity needed to pump water from hundreds of feet underground. Solar pumps of today have no relation to the novelty solar foundation pumps of the past. These systems are high power, low maintenance, efficient commercial products. They are made of stainless steel and feature brushless DC motors, stainless steel housing, and also hygienic and will not pollute water sources. Furthermore, pumping mechanisms made of stainless steel will minimize wear due to the sand and other particles, while lifting water from deep underground. The components that make up solar power well pump systems are very modular. They can be swapped out and upgraded as needed. If increased overcast, low light performance is needed, extra solar panels can be added. If more water is needed per day, batteries and extra panels can be added, so water can be pumped during the night. If volume is needed, the pump can easily be replaced to a higher power model offering higher flow. There are a few mechanical components. Solar panels are highly reliable and do not require any maintenance. Besides a quick wash every year or two, brushless motors do not have brushes and therefore require no maintenance. The pumping mechanisms are highly reliable and are easy to replace in the field. A system should be able to pump tens of thousands of gallons without any maintenance. Advantage financially. Systems are low cost and readily available, not ongoing operation cost, much cheaper than installing main power to remote locations, cheap to maintain. A basic but complete solar well pump system includes solar panels, will cost about $2,000. The baseline system will pump from 100 feet deep at a few gallons per minute flow rate. This basic system will replace most windmills, matching both depth and flow rate. They will keep a large pond full of water with no operating cost or pump enough water for a few hundred head of cattle. After the initial system cost, which is often comparable to other well options, there are no ongoing operation costs. Normal wells burn money every time they turn on the pump. This is not the case for solar well pumps, which get their power from the sun. It's like money in the bank, given to you interest-free and payment-free from the sun. Trenching main power to a remote location is costly in both time and money. There are two items in the solar well pump systems which may need occasional maintenance, both of which are very low cost. Occasionally, every year to two, the solar panel should be given a good scrub with soap and water to ensure maximum performance. Less often, about every 5 years. It is good to replace the pumping mechanism, which can degrade over time and reduce pumping performance. The mechanism costs about $20 and can be replaced in the field. Greatest advantage to solar power pumps. Complete systems can be shipped right to your door. Systems can be self-installed in a single week. Improves property value in remote locations and 30% tax credit on going solar. Complete solar pump kits can be shipped right to your door in only a matter of days. It only takes 2 boxes, one for the pump controller and one for the solar panels to ship directly to your home or office. Solar power well pump systems are very simple and can be installed in a single weekend. All of the solar panel connections are made with waterproof connectors, no soldering required. Remote locations often are less valuable due to the lack of water availability. Solar powered wells would add water to the area, which invites more wildlife or provides water for cattle. Both of these add money in the owner's pockets as revenue is increased. The investment tax credit, also known as federal solar tax credit. Allows you to deduct 30% of the cost of installing a solar energy system for your federal taxes. The ITC applies to both residential and commercial systems, and there is no cap on its value. September 5th, 2019. Disadvantages financial. Initial cost would be the only financial disadvantage. However, it is not as costly as other forms of remote energy options. The initial cost of drilling and installing the well would be the main financial disadvantage for this type of well. However, it is not as costly as not having water available to livestock and wildlife. The fuel and the time spent hauling water daily, or the cost of running some type of power system is the remote location. Disadvantages physical. Unstable pumping is affected by the intensity of sunlight. Daylight length can affect total amount of water pumped daily. The pump does not work at night and in areas without a grid. As with any type of mechanical device, there are always some disadvantages. The primary disadvantage to a solar power system is the problem that arises when there are many cloudy days or longer nights. Without the sun, the solar powered device struggles to keep up. This is why a holding tank would be a great idea when using a solar well. So let's do the math. Water produced. Average solar powered well, 6 gallons per minute. Sunlight typically 8 hours a day. About 70% of daylight is actually sunny, clouds or haze. So 480 minutes sun today by 365 equals 175,200 minutes a year. Average 122,640, which converts to 735,840 gallons a year. Decision made, solar it is. According to Save-A-Lot Solar, the average solar powered well pumps 6 gallons a minute. If a typical day has 8 hours of sunlight, then 480 minutes of sunlight for 365 days equals approximately 175,200 minutes of sunlight a year. But due to the fact that only 70% of daylight is actually usable light, then average usable light is 122,640, which converts to 735,840 gallons a year. This is definitely enough to justify putting in a solar powered pump. Well, this slide shows the comparison of windmill watering systems and the RPS solar pump kit. I have chosen to include this comparison because the primary source for the remote water location has been windmills. However, in the 500 pasture, it is surrounded by hills and has areas the wind doesn't blow as much, which would make the windmill less feasible in this area. This is a pump layout diagram. This is the design of the model we plan to purchase for this location. We have all the necessary tools and equipment, and as well as the manpower to install the system ourselves, saving the owner a lot of money. This is a layout. Here's the plat maps for the 500 pasture on the Bluestem Ranch. As you can see, there are no natural water locations inside the yellow lines. The surrounding pastures and farmland have natural and man-made water locations. The Colorado River runs right through the other side of the ranch, and there are many watershed tanks strategically placed to catch water runoff. This is our layout. Because the 500 pasture needs to be standalone area for cattle, we feel this is the prime location for the solar pump. It is located at the approximate center of the pasture. This would allow for for future lines to be placed in a wagon wheel grazing setup and utilize all the area efficiently, with the water tank being in the hub of the design. And then there's water. Increase in head of cattle on ranch, increase of wildlife population, save money, employees, wear and tear on vehicles, and time efficiency. By adding this one simple improvement, Blue Stem Ranches will be able to support more head of cattle, increase the wildlife population, which is another source of income for hunters, and save money by allowing employees to tend to other jobs instead of hauling water every day. I hope this presentation has made you think about alternative power sources available in today's ranches. Because my boss is very interested in saving money to make money, as well as new technology, I intend to present this proposal to him in the near future. Who knows, maybe the future of the Blue Stem Ranches will shed new light on surrounding ranches, and we'll see a more environmentally friendly countryside. Thank you. And is there any questions?
Once you get this approved by the boss, how long will it take to actually have water available?
Once the well is drilled, it shouldn't take more than a week to probably get it set up and going.
How have you been getting water to the cows in the 500 pasture?
Well, most of the time we've been driving we have a water tank, 1,000 gallon water tank we haul. Usually once a day, it depends on the hot days of summer, it could be more. Thank you.
Thank you.